Experiment 3. Aim. Perform the following chemical reactions and classify them as physical or chemical changes. A. Iron with copper sulfate solution in water. B. Burning of magnesium ribbon in air. C. Zinc with dilute sulfuric acid. D. Heating of copper sulfate crystals. E. Sodium sulfate with barium chloride in the form of their solutions in water. Materials required: Bunsen burner, Petri dish, test tubes, test tube stand, test tube holder, a pair of tongs, sandpaper, distilled water, iron fillings, copper sulfate solution, magnesium ribbon, zinc granules, dilute sulfuric acid, copper sulfate crystals, sodium sulfate and barium chloride solutions. Theory: Physical change. When there is no change in the formation of a substance at molecular level and no change in chemical nature of the substance, such change is called as physical change. In physical change, the interconversion of states takes place. For example, when ice melts, it converted to water, which further could be converted to water vapors upon boiling. These vapors could condense back to water upon cooling and consequently to ice again by the process of freezing. Chemical change. It is a change that brings change in the chemical composition and properties of matter, and a new substance is obtained. For example, burning of oil, fuel. The factors which take place in a chemical change: heat is evolved or absorbed, formation of bubbles, gas or fumes takes place, change in color of the reaction mixture. Reactants results in products. A plus B results in C. Chemical reaction. There are 4 types of chemical reactions. A. Combination reaction. 2 elements or compounds combine to form a single product. A plus B results in C. 2 Mg solid state plus O2 gaseous state results in 2 MgO solid state. CaO solid state plus H2O liquid state results in CaOH2 aqueous state. B. Decomposition reaction. When a compound breaks or decomposes due to absorption of energy, heat, light or electricity to form a simpler substance. CaCO3 solid state in presence of heat results in CaO solid state plus CO2 gaseous state. 2H2O liquid state in presence of electricity results in 2H2 gaseous state plus O2 gaseous state. C. Displacement reaction. It occurs when more reactive metal reacts with the salt of less reactive metal and displaces it to form a new compound. Fe, silver grey, solid state, plus CuSO4, blue, aqueous state, results in FeSO4, light green, aqueous state, plus Cu, reddish brown, solid state. D, double displacement reaction. In this reaction, change of ions occur when solution of two salts are mixed together to form new products. For example, sodium sulfate plus barium chloride results in barium sulfate plus sodium chloride. Na2SO4, colorless, aqueous state, plus BaCl2, colorless, aqueous state, results in BaSO4, solid state, white PPT plus 2NaCl, colorless, aqueous state. Procedure 1. Iron with copper sulfate solution in water. Experimental procedure. Dissolve 1 gram of copper sulfate in 10 milliliters of distilled water. Observation. After 5 to 10 minutes, the blue color of CuSO4 solution turns into green color. Iron fillings get coating of reddish brown copper metal. Inference. Chemical change occurs, shows displacement reaction. Iron is more reactive than copper and it displaces Cu from CuSO4 solution. Reaction of Fe plus CuSO4. Reaction Fe, silver grey, solid state, plus CuSO4, blue, aqueous state, results in FeSO4, light green, aqueous state, plus Cu, reddish brown, solid state. Burning of magnesium ribbon in air. Experimental procedure. Take a small piece of magnesium ribbon, clean it by rubbing with sandpaper, then hold it with a pair of tongs and burn on a Bunsen burner. Observation. Magnesium ribbon burns with dazzling white flame and forms white powdery mass of magnesium oxide. Add MgO, white powder, to a petri dish having distilled water and test it with litmus paper. Inference. It is a chemical change which shows combination reaction. Red litmus changes to blue. MgOH2 is basic in nature. Reaction of Mg plus O2. Reaction. 2Mg, silver color, solid state, plus O2, gaseous state, in presence of heat, results in 2MgO, white powder, solid state, MgO, solid state, plus H2O, results in MgOH2, aqueous state. 3. Zinc with dilute sulfuric acid. Experimental procedure. Take 5 milliliters of distilled H2SO4 solution in a test tube and add a zinc granules in it. Observation. When reaction takes place, tiny bubbles and a gas is released, that is hydrogen gas. Test hydrogen gas by bringing a burning matchstick near the mouth of the test tube. Inference. It is a chemical change and shows displacement reaction with heat evolving out. Hydrogen gas burns with a pop sound. Reaction of zinc plus H2SO4. Reaction: zinc solid state plus H2SO4 aqueous state. Zinc SO4 aqueous state plus H2 gaseous state. 4. Heating of copper sulfate crystals. Experimental procedure. On a Bunsen burner, heat few copper sulfate crystals in a dry test tube. Take small portion of white powder attained in above reaction. Add water to it. Observation: water vapor comes out and condenses near the mouth of the test tube. Blue color of crystals fades and changes into white powder. White solid powder will change into blue. Interference: CuSO4 dot 5H2O loses water of crystallization. Copper sulfate is hydrated. Reaction of heat on CuSO4 crystals. Reaction: on heating CuSO4 dot 5H2O crystals, CuSO4 dot 5H2O, CuSO4 plus 5H2O. Blue crystals of copper sulfate. Anhydrous copper sulfate. On adding water to white powder of anhydrous copper sulfate, CuSO4 S plus 5H2O white solid, CuSO4 dot 5H2O AQ blue solution. Reaction of sodium sulfate and barium chloride solution. Experimental procedure. Take 5 ml solution of sodium sulfate and 5 ml barium chloride and mix it in a test tube. Then allow it to stand for some time. Observation: a white PPT is formed on keeping the test tube on standing for some time. 2 layers of barium sulfate, white PPT, and colorless sodium chloride is obtained. Interference: it is a chemical change and shows double displacement reaction. Reaction of Na2SO4 plus BaCl2. Reaction: Na2SO4 AQ plus BaCl2 AQ, BaCl4 S plus 2NaCl AQ white PPT. Precautionary measure: use all the chemicals in small quantity. Use test tube holder for heating. Clean magnesium ribbon with sandpaper and use fire tongs for holding magnesium ribbon. Use the acids and alkalis carefully. Use of sunglasses is advisable to protect eyes from dazzling light of burning magnesium ribbon. Copper sulfate is poisonous in nature, so don't touch it by bare hands. Use equal amount of barium chloride and sodium sulfate solution. Avoid prolonged heating of copper sulfate crystals, otherwise it changes into brown.